We can start now.
Start. Is my screen visible?
Yes, ma'am.
Yes, ma'am.
Okay. So we'll have a quick recap of whatever we discussed yesterday. So we discussed about database management basic definitions, about data information and knowledge, and then about the file management system. So how it was, how the data has been saved previously, stored and processed previously. What are the drawbacks of the file management system? Its inefficiency and the need for the new system, which is the database management system. So with the help of database management system, we'll be able to create tables and manage the data effectively, efficiently, so that it is secure and the data and the integrity and consistency of the data is maintained. So and then we have discussed about the asset properties, which is atomicity, consistency, in isolation, and durability. So because of this properties, the database management system becomes more efficient than the previous one, which is a file management system. So and the difference between the database management system and the database system is like it is an integral part. Database system includes the database itself, and then the management system, which is a software, and then applications, which is used to interact with the database. So we've been discussing about the online banking system example, which will have a customer detail, account balance, which are transaction as a database, and the software like Oracle, which will help to manage the database, and then an application like any mobile application or a website, which will help to access the database through the software. And so there are advantages of DBMS over the file system. There will not be any redundancy, and the data will be consistent across various versions, and it is possible to maintain the security and privacy with the help of administrator. And there is always the recovery is possible because even in case of system crash, there will be a backup which is ensured by automatic saving of the data. And the basic concepts of like databases are like you have entity, attribute, and tables and record. Records is basically every row of the table. So every row it is called as a record, and every column it is called as a field, and there will be a key field which is a unique identifier, and then we will such tables together will make a database, and that is the top level. So from record, field, table, and then database. So if you take in what example for entity will be a student, and example for attribute will be the any characteristic of a student like a name or age. And there will be many tables like a student table or student course table, something like that. And collection of such table will make a database. So this is what we saw yesterday. So is there any questions till now? Are there any questions? Is it clear? Okay. So there is one more topic which we discussed yesterday, which is architecture. So like we have multiple tier architecture, that also we'll have to go through. After now it is like we'll move on to the next concepts. Like we saw the basic entities, right? So you have the tables. It doesn't mean that the database only have tables. It will also have a relationship between the tables. Each table will be related to each other. Not necessarily, it is not a necessary condition, but mostly every table will have a relationship with other tables. So this is called as relational theory. So in order to work with DBMS, it is necessary to understand the relational theory, like how each table can be related to each other. So we'll see one by one. So what are the type of relationships that they can be there? There are three main types. One is one-to-one, and one-to-many, and many-to-many. I'll explain each one with example. So if you have one or two tables, table A and table B, and every record of table A will be related to only one record of table B. So, for example, a person can have only one passport. A person can have only one Aadhaar card, like that. So, if you have a table which will have details of individuals and another table which will have details of the passport, only one each row of table A will be linked to each row of table 2. It is not possible to link more than one row to the another table. So this kind of relationship is called as one-to-one. So you can, whenever you hear this, you can just relate to one person having one Aadhaar card. The other one is one-to-many. So like, as the name suggests, like you'll have one table where you have, say we have teacher. One teacher will handle many students. So every record in a table A can be related to many records in table B. But each record in table B relate to only one in the table A. So this classic example for this type is teacher to student relationship. And then many to many, multiple records will be of one table will be related to multiple records of another table. So this is usually this requires a junction table. So and here the example would be student and goes via enrollment. So here the enrollment will be the junction table. So you will require three tables here. So this is called as many to many relationship. So, and then reassembling data. So now you have tables and you have tables related to each other. But if you need one information which requires data from every table, then you will need to assemble them together, right? So in that case, we will make use of the structured query language, which is called as SQL. So in that language, we can that language can be used to join the tables. So, but there are certain conditions. There has to be relationship between whatever kind of, it's one to many or many to many. There should be some kind of relationship between the table. If so, then we will be able to join the table. So I'll just read out. Data has been broken down into a table to preserve the integrity. And then we have to put it together. If we want, one table will have student information, another table will have mark information, another table will have the teacher information. So if you want to know, and another will have a course information. So if you want to know the student who scored more than 80 in a particular subject, say maths, then you'll have to get the data from three tables. So how do we do that? What is the way of doing it? We should use a structured query language to do that. So, for example, I'll explain one simple join here. So, we have two tables, order table and customer table. As you can see, order table will have order ID, customer ID, and order date. And customer table, this is one separate table, and this is one separate table. Here we have customer details, customer ID, customer name, and then country. So now if you want to join these two tables, that is like, what can you see the common thing here? Customer ID 2 is the only thing which is common. So we have to, this is a example for SQL query. Okay, so we'll have to select order means here that it is a table name. So you'll select order and order ID and a customer from customer's table, customer name from customer table, and order date from order table. So and then you put an inner join here. It is one type of join. I will explain about inner join. And then you put another table here. So this query will retrieve when the customer ID is same, what is the name of the customer? So the output will be something like this. So as you can see, for the customer ID 2, whatever the name is, the customer name, you will get it here. And you want to know the order date. So as you can see, the order date is 1996. This will be displayed. So inner join means the rows where there is a match in both table will be shown. If an order has no matching customer, it will not be included in the result. Okay, so if this value is in both the tables, that's why we are able to get the output. So this is what is called as inner join. So this is one example how we can derive information from multiple table, when we require certain kind of output, we just give the criteria, we just write the table, everything in the form of this language, and then we will be able to retrieve the information. So, and then primary key is while writing such queries, you will have to know what primary key is and what foreign key is. Primary key is like unique and not null. If you can imagine something like an ID number, you have an ID card, if it is unique for you, it can't be null, it can't be zero. So there should be some value, right? So, but it is unique. Two-person cannot have the same ID number. So primary key is a column or a set of columns. Sometimes even two columns will define if one column can't, like if you have a name, two-person can have the same name, so it can't be a unique identifier. You will need one more column. Say for example, you need to know their second name. Only first name can't be used. You need to know the second name. So the second name. So along the first name and the second name, a set of column also can make a primary key. So it will help you to identify uniquely each row and cannot have null value. Why it is important? If you want to retrieve a data quickly and accurately, like if you want to retrieve a data of a student Ram, then you can just put his ID number, which may be 123, then you will get his details quickly and accurately, and it will ensure that there is no duplicate. And then it will also keep the database organized and reliable. So one way to create it, like how to include a primary key. While you create a table, you can include, or you can also include it in the later stage. I have written one example where we can create a table with a primary key. So we are creating a table, student table, with a student ID, which is an integer, and a primary key. So this is how you create a table. For example, for creating a table. So create table is one query. Student ID, name, and age. These are the columns. Student ID will be one column, name and age. So and then we write the type of it's type, right? It's variable, it's a varchar, it's an integer. Age should be an integer, right? And then student ID should also be an integer. Here we write primary key which is like the one which is a unique identifier. In this table, student ID will be the unique identifier. So we will write next to it that it is a primary key. Understood? Are you with me?
Yes, ma'am.
You understood? This is very basic, and there should not be any doubt with primary key. Okay?
Yes.
And then foreign key is another column. Okay, it is again, it can be a set of column as well in one table that links to primary key of another table. So here you take one table, which is a customer ID table, and then again you have an order ID table. Customer ID in the order table is a foreign key. Here, if you take this is a customer detail table. Here it is a primary key. That's why I've written PK. Here it becomes a foreign key. So it refers to the customer ID. This links to this table. Okay, so you can't insert another ID. Say if you want to write another order ID 103 for a customer ID 3, it won't be possible because if in the parent table there is no 3, only 2 customers are there. So to ensure that there is no wrong value entered, so we should use foreign key. So it is a column or a set of column in one table that links to the primary table of another primary key of the another table. Say here customer ID of the customer table will be linked to the order ID of the order table. It is used to create a relationship between the two tables. This is what you should understand. Primary key helps you to identify a record, identify one value, and foreign key will help you to establish a relationship between two tables in a database. So here, if we want to, so here we will have, which means there is a customer ID 1 who is alive, has an order ID 101, and she has bought a product which is a laptop. So this is two different tables, and in order to, if you want to query, if you want to use SQL to retrieve some information, this primary key and foreign key becomes very important. Understood?
Yes, ma'am.
And then I've also mentioned about this yesterday, database languages, data definition language, manipulation language, control language, and transaction control language. So the few SQL commands which I've written it here, like for DDL, you can see database definition language. It defines the outline of how the table is going to be. Using DDL, you can create a skeleton of a database. So first is you use a DDL to create a table. That's it. You create a table, and then if you want to alter it, like you imagine you just draw the table column, right? That's what you do it in the data definition language. You can't enter the data and all. You can't modify the data. You can't update the data, but you have to create a structure of the database. What are all the things that you can do? You can create a table and you can alter. Like you created a table with 3 columns. Now you want only 2 columns. You don't want another column for a student age. You can just alter it, or you can just drop it also. If you don't want any call a particular row, you can drop it, or you can truncate it. You can also rename an object, and if you want to comment, I've told you about data dictionary yesterday, which will have the details about the tables, about the whatever the tables that is in the database, what are the column, what are the type of data which is stored will be available in the data dictionary, which is also called as, which is in a way is a metadata. So if you want to add a comment about more about that also, you will be able to do it in the data definition language only. Whereas in data manipulation language, you have to use it for retrieval and update. Now you have a database and you need to insert a row. You need to insert, say you take this column, you need to insert the value of Bob. Now you will have to, for creating a table which will have customer ID and name, you need data definition language. And to add the value customer ID to and the name Bob, you will need a data manipulation language. So you can select it, you can insert into the table or update it. You want to change the name or anything, you can also update it or delete the value. Here the drop will alter the structure of the table. It will completely delete a column. Or here the delete will only, whereas in the data manipulation language, the delete will only access the data and not the structure of the table. It will not change the structure of the table. And you can, if you want to select, so this select is, we saw here, right? While using join, we use the select as a select keyword, which means which is a form of data manipulation language. You need to look at the data. You want to see what kind of output it will have. Then you use select query. So that's all. That's all about database language. And I have explained about DDL and DML. DCL, which is a data control language, can be used to control the access by the database administrator, like grant or revoke. You want to grant for example, you have a customer who can access who you want to give access to the database, or if you want only to view the database, or you want to change the database, what kind of access do you want to give them? The database administrator will decide that, and that comes as the data control language. And TCL, which is a transaction control language, commit, rollback, save point, and set transaction. As in, you made a transaction and you want to commit as in save. It will save wherever the transaction is there. And rollback, if you have initiated a transaction and you want to cancel it, then you will come back to a rollback. Or save point, which will save at specific point, and you can also set a transaction. So 4 kinds of, these are like SQL commands, which will be types of SQL commands that can be used. So that's all about it. So is it okay, or do you have doubt? Do you have any doubt? Okay. Please, can you guys just talk, and I want to make sure that everybody is there.
Yes, ma'am.
Is everyone present? Can you just?
Yes, ma'am. We are present.
Yeah, yes, ma'am. Yes, Manikandan is there?
Yes, ma'am.
Pranav Agnihotri?
Yes, ma'am. Present, ma'am.
Yes, ma'am. Sakshi Agarwal?
Yes, ma'am.
Anjali Kumari? Yes, ma'am. Anjali Ranjan.
Yes, ma'am. Present, ma'am.
Swati Paswal. Subhash Singh.
Yes, ma'am.
Shrikant.
Yes, ma'am.
Vineet is also there, right?
Yes, ma'am.
And AMO Chennai. Who are there? Okay. Aman Malik.
Yes, ma'am.
Okay, kindly wait for 2 minutes before you leave. I'll just confirm, okay? Just hold on 2 minutes.
Yes.